Alright, this is going to be a quick video for assignment number 11. The key for it, just to show you how to do it, to make sure you understand it. I'll probably work the first few, or maybe a couple from each section or something, and explain them. Then after that, I'm going to go sort of quick through them. So for number 1 here, we're looking for this angle. First thing you got to do every single time, label the triangle. That's going to be your opposite, because it's across from the angle that we're wanting to deal with, the one that we're looking for. That's your hypotenuse. Then the other side is your adjacent leg. So you got opposite leg, hypotenuse, adjacent leg. Every time you're going to label your triangle with those 3 things every time when you're doing the trig stuff. Then you got to decide which ones you care about. Well, this time we're dealing with those 2 because those are the 2 that we know, and we're looking for an angle. So we're going to set up our trig ratio, and remember our stuff is so, ka, toa. S stands for sine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. T stands for tangent, which is opposite over adjacent. And then every time too, you're going to set up your equation. Your equation is going to be the trig name, then the angle. This is what you write. You write these 4 things every time. Trig name, then the angle, equals, and then the fraction. So we're going to use SOHCAHTOA and then that equation, how to set up each one. So this one we're dealing with adjacent and hypotenuse. Well, that's the ka part. So that means we're dealing with cosine. So we want to say cosine of our angle, which this time is theta, equals adjacent over hypotenuse, so 12 over 13. These angle ones are fairly easy because your calculator is going to do all the work for you once you get the equation set up. So I grab my calculator. And I'm just going to type in, if you're looking for an angle, every time you're looking for an angle, that's where you got to hit the second button. So you're going to hit second, your trig name, cosine, and then you're just going to punch in 12 divided by 13, close the parenthesis, hit equals, and it's going to tell you the angle. They said round the angle to the nearest tenth. If you round it off to the nearest degree, I wouldn't throw a big fit, because that's where I've been telling you most of the time to round angles. But so we'll round this one off. We know that theta for number 1 equals 22.6 degrees. Number 2, same idea. We'll mark the angle. That's one we're dealing with. That's the opposite. That's the hypotenuse across from the right angle. This is the adjacent. This time, we know those 2. So we're dealing with opposite and adjacent, which is the TOA part. So we're doing tangent of our angle, which is theta, equals opposite, tangent's opposite over adjacent. So 4 over 13. Same idea on our calculator. We hit second, because we're looking for an angle, tangent, and it pulls up tangent -1. It's telling the calculator that we're finding the angle, not finding the actual tangent. And then we just type in 4 divided by 13. And we end up with theta equals 17.1 degrees. And again, most of the time, I would probably round that off, since it's an angle, to 17 degrees. Next one, got this angle. We label it. That's your opposite leg. That's your hypotenuse. This is your adjacent. Every single time you just label them that way. So we labeled it. Look at what we have. Again, we really don't care about the opposite this time because we're looking for this angle. So it's adjacent and hypotenuse. which adjacent and hypotenuse is the cosine. So we're going to set up our equation. Trig name is cosine. Then the angle is theta equals adjacent over hypotenuse, so 6/9. So we're looking for an angle, so all we're going to do is take our calculator and hit second, cosine. Again, it pops up cosine -1 because we're looking for the angle. And we just punch in 6 divided by 9, and we get 48.2, we'll say. So theta this time is 48.2. So that's that angle right there. Next one, same thing. I'm not going to explain this one so much. I'm just going to go through and do it real quick. Number 5, same idea on number 5. All these, we're looking for an angle, so I'm just going to do the rest of these real quickly. I'm not going to put my calculator on the screen every time. Just know you're hitting second tangent and then punching that in. I will say on this one, hopefully you can figure out this side's 4. That hypotenuse is 5. This opposite side over here has to be 3. Fits in that 3, 4, 5 triple, Pythagorean triple. We don't need to know that, but something that you should know. This one you should maybe recognize also. If those two sides are the same, then that means these two angles have to be the same. And without even punching it into the calculator, I know each one of those has to be a 45-degree angle. So you could find that, and we could also find this side, which is going to be helpful on your test next week. This side over here, remember, in a 45, 45, 90 triangle, these two sides are labeled with x, and this side's labeled x radical 3. Well, we know x is 3, so this side would have to be 3 times, not radical 3, radical 2. It'd have to be 3 times the square root of 2, whatever that is. That doesn't, not part of the answer. 45 degrees is the answer. All right, next ones we're finding sides, so I'm going to go back and I'll do 2 or 3 or 4 of these, explain them out, then I'll go sort of quickly again. Pick out the angle you're dealing with. That's that angle. Label the triangle. That's the opposite leg. That's your hypotenuse. That's your adjacent leg. All right, SOHCAHTOA up here again. SOHCAHTOA. Just so we don't forget it. This time we want to find this side, and we know this side. So we really don't care about the opposite side this time. Well, the trig ratio that deals with adjacent and hypotenuse is the cosine. So we're going to set up our equation. Cosine of the angle that we picked, and we usually pick the angle that we know or the angle that we're looking for, or we should always pick that, equals, and it's cosine, so it's adjacent over hypotenuse. Well, the adjacent is 11, the hypotenuse is x. First thing we do with these, we grab our calculator and we punch in cosine. Don't hit second. I'm going to clear all this. Cosine, and then our angle, which is 37, and it's going to tell us a decimal, 0.7986. So we go out 4 places. 0.7986. We put a 1 underneath that. Hit equals. Over here we still got 11 over x. Now we're going to cross multiply. We cross multiply this way and we get 0.7986 times x. We cross multiply the other way, and 1 times 11 is just 11. This one's a little longer than some of the others because we actually have to divide here. So we divide both sides by 0.7986. After you get the pattern down on most of these, you're doing the same thing over and over again. So you take that number, that 0.7986, and you're going to, oops, sorry, no you're not, you're going to take 11 and you're going to divide by 0.7986, hit equals. Remember, if you're dividing by a number less than 1, your number should get bigger, so your answer should get bigger. I get 13.77. That tells me to round that up to about 13.8. So the length of that side, that hypotenuse, is 13.8. Remember to look at that and make sure it makes sense. 13.8 should be bigger than the other 2 sides. Well, we know it's bigger than that 11, so that sort of makes sense. Next one, this is the angle that they told us. That's your opposite leg. That's your hypotenuse. This is your adjacent. After you do these for a while, you can probably start to understand, hey, I really don't care about that hypotenuse, so it didn't make any sense to write it down. Those are the 2 we care about. The trig ratio that deals with opposite and adjacent is tangent. So I'm going to set up tangent of our angle, which is 32, equals opposite over adjacent. So x over 13. Grab your calculator and you punch in tangent 32, and it's going to tell you that decimal. So in place of that, we're just getting rid of that word right there. We're letting the calculator figuring out what the tangent of 32 is and getting rid of the word and putting it in decimal form. So 6.249 equals x over 13. Put a 1 underneath this side. We cross multiply. This one's a little nicer because when you cross multiply 1 times x, you just get x. And when you cross multiply the other way, it's just going to give you your answer. So on my calculator, I punch in 0.6249 times 13, and I get 8.1. So the answer to that one, the length of that side is about 8.1. Next one, we're dealing with this angle. That's your opposite. That's your hypotenuse. This is your adjacent. Care about the adjacent and the opposite. Really don't care about the hypotenuse this time. Opposite and adjacent, that means tangent again. So we do the tangent of our angle, which is 50.1 degrees, equals opposite over adjacent, so x over 5. Grab your calculator. You're going to punch in your angle. So I hit tangent. I'll clear all this off. Tangent of 50.1. And I end up with 1.19598, so on, so on, so on. Remember, tangent, it's all right for it to be larger than 1. Sine and cosine, it's not. Make sure your calculator's set up right. So tangent is 1.1960, something about like that. We round it up a little bit. Put a 1 underneath that. We cross multiply. This is another nice one because 1 times x is just x. So when we multiply this way, it's just going to give us our answer. So I take 1.1960 times 5. And I get 5.98. We'll round that up because the 8 tells us round the 9 up, which is going to make it a 0. So we'll round it to 6.0. Next one, we got a 60-degree angle here. If you wanted to use the fact that, hey, if that's 60, this has to be 30, and that other's 90, you could use the 30, 60, 90 triangle stuff. If you remember how to label it, the side across from the 30-degree angle, instead of x, we can label it L. The side across from the 60-degree is L times the square root of 3. Side across from the right angle is 2L. We could do all that. I'm going to just use the trig stuff this time since that's what we've been doing. Either way, it should give you the same answer. So on this one, we'll just deal with this angle. That's your opposite leg. Your hypotenuse is over there. This is your adjacent. This time we care about the hypotenuse and the adjacent. We really don't care about the opposite because we're not trying to find it and it's not something that they told us. Well, the trig ratio deals with adjacent and hypotenuse is cosine. So we do the cosine of our angle, which is 60 degrees, equals, cosine is adjacent over hypotenuse, so x over 11. We grab our calculator and we punch in cosine of 60, and it gives me 0.5. Put that over 1. X over 11 still on the other side. Remember, we're making this into a proportion so that it's easier to solve. We cross multiply here. 1 times x is just x. Multiply this way. 0.5 times 11. 0.5 times 11. And you end up with 5.5. If we would have done it the other way, using the 30, 60, 90 stuff, we would have got the same answer. Alright, the rest of this page, I'm not going to explain a whole lot. I'm just going to run through and do them. This one a little tougher because when we cross multiply here we get 0.8693 times x. We cross multiply this way and we just get 4. This is one of them where you have to divide. So we got to divide both sides by 0.8693. 0.8693. These cancel out, and that's going to leave you with just x equals, and you do that division, and it's going to tell you your answer. So I take 4 divided by 0.8693, and it gives me 4.6. Again, this one again going to be a little harder because x is on the bottom, so you're going to have to, when you cross multiply, then you're going to end up have to divide. First thing you do though is you find your sine of 57, get rid of the word. You want to just do, punch in on your calculator sine of 57, and it's going to tell you 0.8387. Put that over 1, 10.8 over x. And again, you start doing a whole bunch of these and you're going to realize, hey, I'm going to multiply by this decimal, and then I'm just going to take this number and divide it by whatever that decimal was. So that's what I'm going to do on my calculator. I'm just going to punch in 10.8 divided by 0.8387, because when you cross multiply, that's what you end up doing, just 2 steps. And I end up with 12.9. Again, always make sure that your answer makes sense. 12.9 is the hypotenuse. It should be longer than the other sides, and it is longer than the 10.8, so that would seem to make sense. If you know those are the 2 sides that you are going to deal with this time, you don't even have to label the other side really, even though it's the adjacent. We really don't care about it. Now I'm dealing with sine of our angle, which is 37. Sine is the so part, opposite over hypotenuse. So it's x over 10.3. Grab your calculator and you find the sine of 37. 0.6018. Put a 1 underneath that. X over 10.3. Then you're just going to cross multiply. This time when you cross multiply, you just get 1x. So when I multiply here, it's just going to give me my answer. So 0.6018 times 10.3, and I end up with 6.2. Again, that's this opposite side over here, and you can check to make sure your answer makes sense. This side should be smaller than that hypotenuse, which it is. Last one on this page. Adjacent hypotenuse, that's cosine. So cosine of our angle, which is 47, equals, and then it's the c part. So it's adjacent over hypotenuse. So x over 3. Figure out what the cosine of 47 is. 0.6820. If you round something a little different than I do, it's going to make your answer just a little bit different than mine, but not a whole lot. We cross multiply this way, we just get x. So when we cross multiply this way, we're just going to get our answer. So 0.6820 times 3, get 2.046. So we're going to say about 2.0. And if you had 2.1 there, it's probably not too far off, because you could have rounded a little more maybe. Next ones, they say solve the triangles. I'm going to solve two of these triangles, then I'll probably just write the answers in for the other ones without it being on the video, so the video is not quite so long. We'll solve the first one here. If we're dealing with that angle, that's 62 degrees. Easiest thing, if they tell you two angles, easiest thing is to find the third angle. So I know that 62 plus 90 is 152. Subtract that from 180. And I end up with 28 degrees. So this other angle over here has to be 28 degrees. So I know the measure of angle A is 28 degrees. When it says solve the triangle, again, you're just finding all the missing parts. So I'm going to find all three missing parts. So that's one of them, that angle. Now I got to find these other two sides. Again, labeling these triangles. If this is a big A over here, probably what you want to label this side over here with is normal is a little a. If this is a big C, then over here a little c. This over here would be little b, but we already know it, so we're not going to put anything in there. Whatever the angle is, it's going to be a capital letter. The side across from that is the lowercase letter of that same thing. So if I pick the 62 degree angle, I label the triangle accordingly. That's the opposite leg. That's your hypotenuse. This is your adjacent leg. As you do some of these, we're looking for both these, A and C, but we can only find them one at a time. So we have to use the number that they give us, and then we just pick one of them. I'm going to pick the hypotenuse. As you do a bunch of these, you'll see sometimes, hey, it's easier to do it, find one thing first, and then find the other things. And I already know that since I've been doing it so long. So I know that this is, I don't know that this is going to be easier. It's going to be about the same, but that's one I'm going to find first. I'll tell you what, I'm not going to find that one first. I'm going to find the A first. So we don't care about the hypotenuse. Let's find A first, and then we'll use Pythagorean's theorem. So if I do this, opposite and adjacent, I know that's the tangent of our angle, which is 62, equals the opposite over the adjacent, 22.6 over little a. I grab my calculator and I figure out what the tangent of 62 is. And it comes out to be 1.8807 equals 22.6 over A. Put a 1 underneath that. We're going to cross multiply, and we get 1.8807 times A equals 22.6. We divide both sides by the 1.8807 to get the A by itself. If you wanted to use X there instead of A, you could have. It doesn't matter. So all we're going to do is divide these two, and that's going to give us our answer. 22.6 divided by 1.8807. This time your answer should get smaller because you're dividing by something that's bigger than 1. And it comes up 12.0. So one of the sides is 12.0. So we now know this side over here where we had A, that's 12.0. So we found this side, we found this angle. The only thing that we have left to find is the hypotenuse there. And the way I'm going to find the hypotenuse is I'm going to use Pythagorean's theorem. Should have done my work a little neater here. But if I know the two legs, I can use Pythagorean's theorem. Remember, it's a squared plus b squared equals c squared. Where a and b are the two legs, c is the hypotenuse. So I'm going to stick in 12.0 squared plus the other leg, which is 22.6 squared equals c squared. All of this right here on this side, I can stick that all into my calculator. All is one thing. So 12.0 squared plus 22.6 squared, and it gives me 654.76 equals c squared. Now all I'm going to do is take the square root of both sides. The square root of c squared is just going to, the square root and the little 2 cancel out. It's just going to end up being c. So all I really have to do is take the square root of that 654.76, and I end up with about 25.6. So that hypotenuse over there we're saying is 25.6. Again, check your answers. Remember, the hypotenuse should be longer than the other two sides, and in this case it is. And you can also use the stuff that we learned a long time ago, where the smaller the smaller angle's got to be across from the shortest side. So the 28 degree is the smallest angle, and it is across from the shortest side, and that should all make sense. So that's solving the triangle. I'm going to do problem 18 here. 51 degrees. If I just do 90 plus 51, I get 141. Subtract that from 180, and you get 39. So the measure of angle B down here is 39 degrees. That's one of our answers. You can pick whichever angle you want to find the other parts. I'm going to just label it real quick. If this is big C, then this over here would have to be little c. If this is big B, this has to be little b. Then whichever angle you want to pick, maybe you like the 39 degree angle for whatever reason better, pick it, use it, it doesn't matter. That's the opposite leg. Side across from the right angle is the hypotenuse. The thing that does matter is you have to label these triangles opposite, adjacent, and hypotenuse when you're doing the trig, otherwise you get confused. If we want to find, let's find the hypotenuse, or let's find the opposite first. It's going to make it a little easier. If we find the opposite first, and we use this adjacent that they told us, well, the trig ratio that deals with opposite and adjacent is the tangent. So I do tangent of the angle that we picked, which was 39. Again, we could have picked the other angle. It just changed the way that our stuff is labeled. Equals the opposite leg, which is B, over the adjacent, which is 9. Notice the variables on top this time. That's a B, not a 6. The variables on top, it should make this a little easier. So I grab my calculator, I do tangent of 39, hit equals, get 0.8098. Put a 1 underneath that. That equals B over 9. If we cross multiply, and this is where it's going to make it easier, because 1 times B is just B. So our answer for B is just going to be whatever 9 times that decimal is. So I do 9 times 0.8098, and I end up with about 7.3. So this side up here is 7.3. So we found this angle, we found this side. Now we still have to find the hypotenuse here. Again, we could use Pythagorean's theorem. This time I'm going to just use what they told us with the adjacent and the hypotenuse and the 39 degree angle. And I know adjacent and hypotenuse is cosine, so I'm just going to set up a trig ratio again. So cosine of 39 equals 9 over the hypotenuse, which is C, adjacent over hypotenuse. Now I punch in my calculator, cosine of 39, and I get 0.7771 equals 9 over C. Put a 1 underneath this. So you're going to cross multiply, and then you're going to have to divide. So I'm just going to take this 9 and divide it by that, and that's what C is going to end up being. So 9 divided by 0.7771, and I end up with about 11.6. So that hypotenuse right there is about 11.6. So I found this, I found that 39 degree angle. Again, you can look at it, the hypotenuse is the longest side, so that makes sense. Those are our 3 answers. So 19 and 20 I just worked out and wrote the answers down here. On 19, just to explain it real quick, I knew 2 of the angles, so I went through and found the 3rd angle, because 3 angles of a triangle have to add up to 180. I set up these 2 equations, labeled the triangle, did all that stuff, set up this equation. I didn't work out every step on here. I did tangent 42 equals 4.5 over a, and I just solved it, and I got a equals 5.0. It's going to be the same as, you know, the way we worked out the others. Then the other equation I set up was sine of 42 equals 4.5 over c. Again, to find that third side, you could have used Pythagorean's theorem, but I just used the trig ratios both times. Same thing over here. I found the other angle first, came out to be 37 degrees. Then I set up the equation sine 53 equals b over 5, solved it, got this. I did cosine of 53 equals a over 5, solved it and got that. So those are the answers. Next one, these are a couple word problems. This is what the next assignment's going to look a lot like, is these word problems. You got to draw the pictures. It says you are launching a model rocket and want to figure out how high it goes in the air. You stand 100 feet from the launching pad and measure the angle of elevation. Angle of elevation, remember, is going up. To its highest point is 77 degrees. How high was the rocket at its highest point? So you're standing here, you're blasting off this rocket over here. It's 100 feet from you. It goes up in the air. You measure the angle of elevation. Remember, that angle of elevation is going up, so that's this angle, and that's 77 degrees. Hopefully your rocket went straight up and not flew sideways somewhere. So that's a right angle. You want to know how high the rocket went, which would be this side over here. Same idea on most of this. This is the angle we want to deal with because that's the one we know. We could find the other angle and deal with it, but no reason to do the extra work. We never ever pick the 90-degree angle. We label the triangle. That's your opposite leg. That's your hypotenuse. This is your adjacent leg on this side. The ones we care about this time, we're looking for the opposite, and we know the adjacent. The trig ratio that deals with opposite and adjacent is tangent. That's the TOA part of SOHCAHTOA. So we write down tangent of our angle, which is 77, equals the opposite, which is x, over the adjacent, which is 100. We grab our calculator and we punch in tangent 77 to get the decimal answer, and it's 4.3315. That's still going to equal x over 100. We'll put a 1 underneath that. We're going to cross multiply, and when we cross multiply this time, it's just 1 times x, so it's just going to be x equals, and it's going to give us our answer when we do the other cross multiplication. So 100 times 4.3315, and some of you probably could have done that in your head, and it didn't tell us how to round it off, so we'll round it off to the nearest tenth. It's 433.2, and our units were feet, so 433.2 feet. That's how high your rocket went in the air. Next one, a 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building, or from the wall. What angle does the ladder make with the ground? So you got your building here. Hopefully all of you know that your ladder is not going to stand like that pin right there. It's going to lean up against the wall. So your ladder leans up here like this. Hopefully the building makes a right angle with the ground. It says it's a 20-foot ladder, so we know that that ladder length right there is 20 feet. It's 8 feet from the base of the wall. So that bottom side down there is 8 feet. And we're looking for this angle. So we can call it theta, we can call it x. I'll just call it x this time to make it easy. So we're looking for that angle. We label the triangle according to that angle. That's your opposite leg. That's your hypotenuse. The ladder is your hypotenuse. And then this side down here is your adjacent leg. The ones we care about this time, adjacent and hypotenuse. SOHCAHTOA, that's the ka part. So it's cosine of our angle, which we don't know, so that's x, equals the adjacent, which is 8, over the hypotenuse, which is 20. These are the easy ones if you're looking for an angle, because your calculator is going to do all your work for you. You're going to hit second, cosine, and then you're just going to type in that 8 divided by 20. 8 divided by 20, because we're looking for an angle. Remember, it comes up cosine -1, and we get 66.4. We'll round that off to about 66 degrees. So the measure that the angle that the ladder makes with the ground is about 66 degrees. We could figure out how high up the wall the ladder goes using the trig or Pythagorean's theorem, any of that stuff. Again,